Somewhere in your house, you probably have a drawer dedicated entirely to obsolete cords, a tangled mass of plastic and wire that you hold on to just in case you ever need to charge an old camera or an e-reader from 10 years ago. Take a look at this lineup of early cell phones. For decades, buying a new piece of hardware, whether it was from Nokia, Motorola, or Samsung, almost always meant bringing a completely new, physically distinct charger into your home. Every device spoke its own language. Setting up a basic workstation required a separate, specialized cable for every individual task. You needed a barrel plug for power, a USB Type-A for your mouse, and a massive connector like this HDMI cable just to send video to a monitor. This physical chaos created a severe bottleneck. Hardware manufacturers wanted to build thinner, lighter, and more integrated devices, but they were physically restricted by the variety of massive ports required to keep those devices functional. This bulky 1990s desktop setup is exactly the environment where the original Universal Serial Bus, USB, was published in 1996. Back then, standardizing a connection for keyboards and mice was a massive achievement, but the hardware footprint was huge. As electronics shrank throughout the 2000s, that large USB standard couldn't keep up. Instead of a unified solution, the industry splintered. We got mini USB, then micro USB, alongside dozens of unique power bricks. The drive for smaller devices actually accelerated the fragmentation. Looking at crowded electronics expos from this era, you can see the commercial reality driving the mess. Hardware companies were highly competitive, and keeping a proprietary port on a device was an easy way to lock consumers into a specific ecosystem of branded accessories. A single unified cable seemed entirely impossible. The major players simply valued controlling their own hardware ecosystems far more than they valued consumer convenience. That changed quietly in 2014. The USB Implementers Forum published a new standard, designed with a singular, ambitious goal: to create one connector, compact and capable enough to absorb every other cable on the market. The first major engineering triumph was purely physical. The new USB-C design was perfectly symmetrical. With older USB-A or micro USB cables, you had a 50-50 chance of getting the orientation right, which usually meant fumbling, flipping the cord over, and trying again. USB-C eliminated that entirely. Achieving that simple user mechanic, the ability to reach blindly into the dark and plug in a device on the first try, was the crucial first step to getting the entire world to adopt it. To make that simple exterior work, engineers had to pack an immense amount of complexity inside. This is the interior schematic of a USB-C connector. It houses 24 microscopic pins arranged in a tight grid. The secret to its reversibility is math. The pin layout is mirrored. If you plug it in upside down, the top pins align with their redundant counterparts on the bottom, guaranteeing a perfect connection either way. These pins are engineered to carry immense power. Today, the standard can handle up to 240 watts, high enough to replace the heavy, dedicated laptop barrel charger with a single, slim wire. At the exact same time, dedicated data pins can transfer files at speeds reaching 40 gigabits per second, making older, specialized hard drive sync cables obsolete. Engineers successfully compressed a massive, multi-lane digital highway into a physical footprint about the size of a grain of rice. The symmetrical shape hides a complex, high-density infrastructure. To understand how it devoured the rest of the market, you have to understand that USB-C is really just a vessel. The physical shape of the metal doesn't dictate what flows through it. The background standard does. Because of this flexible architecture, those 24 pins can be reassigned on the fly to carry high-resolution video up to 8K, actively cannibalizing the need for dedicated display cords. It can also carry subtle audio waveforms. This capability is what allowed modern smartphones to finally drop the century-old 3.5mm headphone jack. The connection is incredibly smart. Tiny controller chips inside the devices actively negotiate the moment they touch, instantly deciding how to divide those 24 pins among power, data, video, or audio, depending on what you've plugged in. For the first time in the history of consumer electronics, the physical shape of a plug was totally decoupled from its digital function. Over the last 10 years, older connector shapes simply faded out. Headphones, external monitors, and rapid chargers all slowly replaced their unique physical ports with the exact same tiny metal oval. Even the most stubborn holdouts eventually gave way. In 2023, Apple officially retired their proprietary Lightning port, transitioning their flagship iPhones over to the new standard. The final mandate for this shift arrived in 2024, when the European Union's common charger rules went into effect, legally requiring USB-C on almost all small and medium-sized portable electronics. But while regulations forced the final step across the finish line, USB-C won the broader market naturally. Its internal architecture was simply superior and far more adaptable than any individual cable it replaced. And so, that messy drawer in your house slowly got smaller. The dozens of different wires you used to need have largely been reduced to one reliable shape. Universal was never really a technical specification. It was a deliberate choice by a group of engineers to finally simplify connectivity. By building a connector capable of carrying anything, they quietly organized our fragmented hardware into a single ecosystem. And somehow, your entire digital life started fitting through one tiny 24-pin port in your pocket.